Today, we're looking at some flow rate problems. For the first example, the prescriber ordered 1/4 normal saline, 850 milliliters IV in 8 hours. The label on the box containing the IV set to use for this infusion is shown on the label given. Calculate the flow rate in drops per minute. So they're telling us the thing we want to end in is drops per minute. If we look at what else they give us, they tell us that we're infusing 850 milliliters in 8 hours. So that is one of the flow rates, or one of the ways to write the flow rates. Then they also told us to look at the label on the box. And in this label, they tell us that in every 10 drops, there's approximately 1 milliliter. So because I want to end in volume over time, that's how I'm going to start my dimensional analysis. So I'll start with the 850 milliliters over 8 hours. Now I want to get rid of those milliliters, so I'm going to use the drop factor from the label. I know I need milliliters to be diagonal from each other, so I get to use the 10 drops over 1 milliliter. I have the volume that I want, but now I need the time that I want. So I need to get 1 hour into minutes, and I know there's 60 minutes in each hour. When I multiply straight across, that gives me 8,500 over 480 drops per minute. But I know I need to do that division. When I divide them out, that gives me 17.17083 repeating. Now we know with flow rate, drops per minute and milliliters per hour, they need to always be rounded to the nearest whole number. So that 7 tells me to bump that 17 up. So I end up with 18 drops per minute. And as a note, we're going to say flow rates, we always round to the nearest whole number. Let's look at our next example. The prescriber orders dextrose 5% solution in and half normal saline IV to infuse at 21 drops per minute. If the drop factor is 20 drops per milliliter, how many milliliters per hour will the patient receive? So we want milliliters per hour. They tell us that we have an infusion at 21 drops per minute. And they also tell us that we have a drop factor, 20 drops per milliliter. So if I look, I'm still looking for my answer in volume over time. So I'll start with the 21 drops per 1 minute. It's still a volume over time. I need to change that volume, so those 21 drops I want to change to milliliters. So I'm going to use this 20 drops per 1 milliliter, but I need to flip it so that the drops will cancel out. The 1 milliliter remains up in the numerator. Now I need to get that time correct. I know there's 60 minutes in 1 hour, and I set up my minutes to be diagonal so they'll cancel each other out. When I multiply straight across, that gives me 1,260 over 20. And when I divide, that gives me 63 milliliters per hour. That is already a whole number, so I do not need to round.